And I got my, I've heard people talk about different things of covering a tool. This is a piece of Cheerios cereal box. And just masking tape around the outside. Covered. Okay, so I want to put some decorations on the lid. And you see I've got some different patterns I've got here. When I first started playing with this knurling tool, I think the first time I tried it, I got a pattern and I said, wow, I like that. And then I tried and I was never able to duplicate it. Couldn't get the same thing. Well, there's a lot of variables involved with that. Once I started thinking about it, there's a lot of things that can change. You want the center of this to be at the center height of the spindle. Well, for the pattern that I do anyway, you can do it other way. So if this is at the center height of the spindle, I want this axis to correspond with this axis. So I'm cutting right on the center line. Well, if I go down like that, my axes are no longer aligned. If I go up like this, my axes are no longer aligned. So when I got it on the center line, when I'm cutting that, at that point of cutting, the wood is coming straight down across that knurling wheel, and it's going to give me the pattern that's in the knurling wheel. And if I get it high or low, it's going to be a shearing coming across to the shearing angle, and it's going to be tearing fibers out, and it's going to give me some other pattern. Well, then another problem is that if you draw the circumference at about 1/4 of an inch, that's a radius of or diameter of 1/2 inch, so half of 3.1, what pi is 3.14, half of that would be the circumference of that point. It'll come out here at 3/8 of an inch, that would be a total then of about 3/4 of an inch, so 3/4 of that would be a considerable difference amount. So the velocity of the wood on this side of the tool is much considerably less than the velocity out here. So depending on what portion of that wheel is spinning against the wood is going to determine the RPMs of the wheel. So if I'm contacting it out here, it's going to have 1 RPM, and this is going to be turning much faster here than what the wood is down here, so it's going to get a tearing effect, because it's not just going to go in and punch a hole, it's going to be ripping because there's different velocities between the speed of the tooth here and the speed of the wood going past it. So I've come up with a way to sort of help me get repeatable results. So let me clean up this surface here first. I got ahead of myself there. I need to clean that up. This is my tool of choice, this little round skew is for cleaning off that end grain. A little bit cut. Let me make it a little bit convex instead of concave. So on the you look at this tool, it's not the same on both sides. If you look at the distance between the points there, as opposed to the distance between the points there, there's 3 rows of diamonds across there, and I've got a full diamond there, a full diamond, and a half a diamond over here. So the tool doesn't give you the same pattern both directions. So that's another variable is be aware of what pattern it's going to give you a different looking pattern. What I've been using is with the part diamond on the outside edge. And to get rid of the problem of being able to hold it level, now I don't have that problem anymore. The only problem I got now is how I'm gonna cock it this way. And the pattern, the profile that I've come up with to give me sort of a duplicate, a repeatable profile, a repeatable pattern. As I got the center point of the rope of there, and I put the center point about right in the middle of this arm of it over here. And then when I push it in, I try to put right. I don't try to go on either side. I just try to go straight in as straight as I can get it. And since that's a little bit convex surface, it should hit and control the speed from on the center of the wheel here. And I'm going to run it at about 1,000 RPMs. And the pattern that you get, if the circumference, wherever the circumference on there is an even multiple of one of these patterns of teeth on here, then at that point you're going to get a nice indentation of every time that wheel comes around, it's going to fit in the same hole. But if it comes around and you got a multiple of 2, then like down here I've got, where when I come around it's still got indentations there, but they're not the same ones. Out here I've got pretty close. This one here is probably the closest out here of being matching. You see down here I've got a little bit of double hit there where it's not exactly the right diameter. But that gives me, since I went to that with this and putting it in that place there, I can get pretty much the same pattern every time. Okay, so now I want to cut some more off of here. I want to raise that up, that detail. I want to raise it up so it's a little bit proud. Okay, I'm going to use this as a spindle gouge. And I've got there's a very, very small amount of flat bevel right behind the cutting tip, about maybe less than 1/8 of an inch, and the rest of it is rounded over, so I don't have a heel there to mar up the wood behind the cut. And I've got always just a tool wrist so that when holding it at a proper angle, I've got it pointed directly at the center. Now when I enter the cut, I always start on the point, and I want to have that point to be completely vertical. If it's cocked that way, it's going to try to skate back across that way. If I have it like that, it's going to cock across there. I've been reading articles in American Woodturner, which is an AEW journal, and several people in there said you start down here like this and you rotate it into the wood. Well, it worked okay for me a couple times, but then I got to skate back also doing that way. So I'm going back to my method of doing it, which I think I a little more confidence in. So I anchor my finger or thumb on here to help control the movement of the cutter, of the tip. And then once I get some area to rub in, then I can roll it around a little bit like that. And I'm just going to go down to where I just come up against that pattern. So that raised it up, got it away from the, so it just makes it a little bit proud. Okay, now I could improve that surface. It's pretty smooth, but I could improve it with some sanding. But since we don't really want all that dust in here and it takes extra time to do it, I'm just going to show you what you can get as a final product just by getting slicing cuts. And like I say, several of those have passed around. We're sanded down to about 1,500 grit, and then I put the beeswax finish on them. So I'm just going to do this without any sanding so you can see what you can do Want to get rid of that sharp curve, sharp edge there. Okay, so now I want to mark down for my, this is 50 millimeters. I want my lid to be 11.8 millimeters. So I'll make it just slightly under 12. That's going to be the height of my lid. Now I'm going to turn this, we're going to, I got it in this orientation here, I'm going to part down to this tenon here, down to the depth of that tenon, which is going to give me the diameter of the thickness of the wall of the lid. So my parting tool is about 2 millimeters. I want to leave about a 4 millimeter spacing for the tenon here, and that'll give me an extra millimeter. So I'll come down, I'll say 4 plus 6, 7 or 8 millimeters down. I'll put another mark. We'll go down 8 millimeters just for a fudge factor. You always take a little bit off of the. So this is one reason you'd want to make that as narrow as possible. If your grain has got any kind of diagonal movement in it, the least amount of wood you take out of here, once you take that wood out and then put the two pieces together, if it's going at a diagonal, your grain is not going to match up on the box. But this is pretty straight grain. There's one section right here where it's got that loop there, but pretty much over here side grains, that's all going to match up pretty good here. We'll see a little bit of difference right here because that's going to be coming down and matching here, and that's not the same distance as there. So that's why you don't want to take out any more than you actually have to. Okay, I'm going to use this oval skew. And what I do is if I just went in there with a parting tool to remove that material, it would try to tear the fibers out here and here, and I want that to be my finished surface there. I don't want any torn fibers there, so I'm going to just make a shallow cut there just to break those fibers on the surface. And what I'm going to do is I'm going to take this bevel, I'm going to put it so it's going straight in, and I'm actually going to do a little push on it with my thumb here to keep if I just went straight in, I would curl up a little bit on both sides of that cut I'm making. So I don't want to curl this on the lid side of that cut. I don't want to curl anything up there because that's my final surface. So I'm going to come in here, put the point right on that line, and I'm going to push to my left on that side. Then I'm just going to do the opposite over here and push to my right. So now I don't have any raised area there or here. Any raise is going to be there on that part that's going to be coming out. Okay, I got a parting tool. I'm just going to go in and go down about 2 or 3 millimeters. I want that to be perfectly straight across there because that's going to be my tenon. You know, the loose fitting lid is not quite so critical. So there's almost about 2.5 millimeters, which is good. So now I'm going to finish that off. That was pretty much a scraping cut, slightly peeling, but more scraping than peeling. So the surface is not too bad there, but it could be better. So what I'm going to do to clean that up. So I started out with a square piece of high-speed steel, and we'll put a bevel on it. And then this side over here has been relieved a bit, so when I'm making the tenon later on, this down here won't get in the way. Let me relieve it. Where this side over here is square, still square. So I want to put it upside down, like the Europeans use their bidan. And I'm going to get up here, start up here, and then bring it down and get a straight feeding cut, just to clean that up. A little bit there still yet, then a little bit off of that ridge there. Okay. So the next thing I want to do is I want to cut this the little relief shoulder here. There's just a shoulder right there. This is the flange. It's going to go up inside the box, and this is just acts as a spacer between the lid and the box. And what that does, it gives you a bit of a shadow line. And also, if the surface of the lid was directly against the surface of the box, any difference in movement between the two pieces, you'd more readily feel it, because with those two together like that, with that little gap in there, you don't feel the differences in diameters if it does move. Since this is both out of the same piece of wood, any shrinkage, both pieces should shrink the same amount, so you really shouldn't see that much difference as long as you have the grain lined up. But that's what that little ridge is for, is a shadow line, and then just a little bit of a separation between the lid and the box, so you don't notice any differences in the diameters over age. Yeah. So I'm going to make that about 1 millimeter high and about 1 millimeter deep. Okay, again, I want to break those fibers on that edge. They get a little bit of a raised on that surface right there. Just trim it off. Okay, so now we're ready to part the lid off. But before, well, no, I'm not ready to part the lid off. I'll go ahead and I'll part down a bit. And when I do this now, I want to leave this flange right here. I want to leave a little bit up here on the lid. And what that gives me is a witness mark showing me how much I need to hollow out of the lid to be the exact diameter of the flange on the body. So I'm going to part that off, leaving about less than 1 millimeter or so on the lid, just to use the witness line. You see there, I've got just a little bit of a step right there, and that'll be my guide when I start hollowing out the lid of how far I come out to match this diameter here. Okay, so now when the lid is finished, we'll go ahead and put some. It's finished, so I'll start finishing. What I'm using for finish is beeswax. And for lubrication, I just use a little bit of mineral oil on the pad, just for lubrication. Just move it around a little bit. Okay, I'm going to run the speed up to about 1800, 2000 again. I want enough speed to melt the wax. Just put pressure from the cloth. Now I am using a cloth here. You know, they always say you should never use a cloth on the lathe. Well, I've got a very small piece of material here, and if it should catch, it's just going to pull it out of my hands. I'm not wrapping it around my fingers. I don't have a big wad that would be wrapping around my fingers and get caught on something. So I've got a I'm using a very small piece of material, and if it should get caught, it would just pull out of my hands. I think it's actually a gun cleaning pad. I think a Walmart little pack of strips meant for cleaning guns. So it's a finish now. If I did get a little bit of wax in my figure, usually the wax just melts in there, but I can just use my brush to clean that out. So that the lid is finished. Let me go ahead and part it off completely. Now to do the parting, I don't part it off completely with the tool because I don't want to, and on the lid here it really doesn't matter because it's going to be hollowing. But on the base, I don't do it because I don't want it to tear out. When it gets down in the real fine fibers, it would end up tearing out, and I wouldn't want it to pull out and make a pit in the bottom of my box. So I'm going to do the same thing here. I'm going to go down to about a quarter of an inch or so. And then I'm going to finish it off with a saw. When I first started using a saw, I was out there like this cutting, and then when it cut through, where'd the saw go? But down here and break a tooth of my saw and put a dent in the bed of the lathe. So this is my saw stop right here. Here's the lid.
Dan, what kind of saw is this? Where was it from?
Right out here. I don't know if they still have them. I've had it for several years. But yeah, they had a set. It was one of the weekly specials they have. It was 2 saws.
Yeah, I don't know a lot of the Japanese style saws out there, but the traditional is one piece.
Yeah, I got it right out here. It came from the store here.
Okay.
Like I said, it may have just been something special they had on their weekly internet special. Okay, so now we're ready to hollow out the base. And the base diameter, base depth is going to be 19.1 millimeters for my chart. So I'm measuring from the top of that flange there down, let's say 19, it would just be 19. Okay, now I'm not going to put a line all the way around it, because when I start hollowing out, if I get a little bit too aggressive and go deeper than what I really wanted to, I'd have to move my bottom down. If I made a line all the way around, I'd have to worry about getting rid of that line. So I'm just going to put just a little bit of mark there, just to set my depth gauge. And I'm going to come in and leave about, say 3 millimeters to finish off the bottom. See about, can't see the line. There's my pencil line there, and I want to hollow it down that far. So I'm going to leave about 3 millimeters between the inside bottom and the outside bottom.